Clear? Okay. Okay, in the same code only, in the same program only, we are accessing two Excel sheets, set A, set B. In that both Excel sheets, I have different types of sound heartbeats. All the four types of heart sounds I am considering, accessing in the same code, training that algorithm, that is neural network, and getting my output prediction. Okay, 70% on an average, 71, 73 in between, we are able to predict. 70% is not a joke, because it is a healthcare domain which is very important. On this domain we are getting 70% accurate result, means it is not joke. It means more than half, more than 70% we have a chance to get know whether the patient is having heart disease or not in the early stages. So that directly we are increasing, or we are knowing the patients who are affected with heart disease. We are saving a person. It is a very big thing. Okay, so I hope everyone enjoyed. I also deleted I could understand that was the same query, so I deleted, ma'am. I could understand that. Okay, fine. So I hope you understood something, right? So we'll wind up the session now. Any queries yet to be clarified? Many people asked the queries. I hope everything is cleared. I have answered everything. Yeah, Anwar, thank you so much for encourage. No issues. We will give you the support not only in this domain. We are giving in different technologies, programming languages. If you are really interested to develop your skill set, you can just join our classes or sessions and just listen. It will be helpful for your career development. Okay, to set your career development. Okay, so we'll wind up the session for now. And last but not least, if you like the session, please do like, comment, share to your friends, which is very most important, who are really interested to learn something practically for their future, who are trying to build their career. Please share to them. That is useful for them. For one or the other, it will be useful. If possible, you can even put it as a status. Whoever is interested, they will just join. It might be helpful for them. We don't know, right? So even share. And if you are the first time visiting to our PantecheLearning channel, please do subscribe to PantecheLearning channel. Thank you all. Have some delicious dinner and take care. Good night. Remaining doubts tomorrow. It's time up. Okay? Is it okay, Soumya?
Am I audible, guys? So if I'm audible means please command me in comment box. Am I audible? It's going. Sorry guys, some technical issues. Good evening. Yes, good evening. So this kind of a comment I am expecting. Yes, good evening. Yes, don't call me sir, call me Philip. Yes, good evening. Usha, good evening. And Surya Prakash, there's nothing happened, some technical issues. Vineet, good evening. Shreya, good evening. Yes, now I am audible, right? Yes, now I am audible, right? Good evening. Yes, guys, thanks for the good reply. Hi, Rani, hi. And Pavitra, happy evening. And Gamer Dog, good evening. Janaki, good evening. Yes, one person mentioned my name. Thank you. Yeah, most of the people commented very well. Thank you so much. It is more encouraging to me. Right, so it is also very interactive too. So don't forget to, like the session. So don't forget to like the session, and also your support is very needed for us. So that will be more encouraging to, conducting the next techniques also. Okay, right? So don't forget to like the event, and also, do subscribe our channel. Okay, click the like button, my dear friends. Click the like button, and if you like means click the like button. Okay, fine. So now without delay, I'm going to entering the today's session. Okay, already it is 8:04, right? Okay. Hello everyone, very good evening. This is Philip Edit from PantecheLearning, and I welcome you all for engage your learning experience with PantecheLearning anytime, anywhere, and any places. And we are always here for you to support the students, and also we are help to 10 million students to learning in an easy way, and that is our main vision. And I welcome you all for day 4 Computer Vision Masterclass. Okay, so I welcome you all for day 4 Computer Vision Masterclass. So what is the topic today? What we are going to cover today itself, in the sense this picture will say. Definitely this picture will say about that particular topic. So what is your understanding about this picture, guys? So what is your understanding about this picture? So this picture will say something about today's concept. So if you are understanding about this picture will say something to you today's topic. Okay, so what we are going to cover today itself, in the sense this picture will say something about that. Okay, so what is your understanding about this picture, guys? Please reply me in comment box. So what is your understanding about this picture? Please comment me in comment box about your understanding about this picture. Yes, Sanjay, yes, exactly. Edges, outlayer, yes, black and white image, okay, line diagram. Not like that, it is related to the edges concepts. So most of the people answered it is related to the black and white, object detection. Yes, good evening guys, good evening. I'm asking about this picture. So what is your understanding about this picture? So most of the people answered black and white. Okay, so maybe that if you are thinking apart from the subject, or apart from the computer vision, in the sense it may be the black and white, right? Yes, invert edges of the object, black diagram, object location. Yes, happy evening. Yes, most of the people answered very well. Thank you. Thanks for your good reply. So this particular picture will say something to you, in the sense it is related to the edge detection from the image. So what is that exactly edge detection, in the sense when you are going to enter one particular object detection concept. So what is the basement of the computer vision? So once you are going to recognize one person, or face detection, or mask detection, this kind of the things, in the sense that is that particular task. So only one basement is there in computer vision, that is object detection. So the basement of the computer vision, the main objective of the computer vision is mainly object detection. So once you are going to do something related to the object detection, in the sense edge detection is very important. Most probably, what is your consideration about the edges, in the sense it is related to the boundaries. What is that exactly, in the sense it is nothing but the end of the one particular object, at end of the one particular line. So that is edges. And maybe that it will be called like details in that particular object, or details in that particular image, right? So these all are the concepts today we are going to discuss. So what is the topic today, in the sense edge detection from an image. For example, once the camera is capturing me, right now the camera is capturing me, the live is going. This kind of the process is going presently right now. But the camera couldn't understand where is the edges. Because we can recognize we can identify, we can detect with the help of your eye, yes, this is my, edges, right? This is my edges because of my outline, right? But when you are going to apply one kind of the concept, one kind of the task in computer vision, in the sense that will be say exactly your outline of the image. Clear now? So this kind of the concept we are going to discuss today. Yes, good evening, good evening. Yes, Murali Krishna, good evening. Yes. So who all are excited to listening to today's class? So who all are excited to listening to today's class? If you are excited means raise your hands in comment box. Am I audible? Am I audible, guys? Hi, I'm audible. Just a minute. I'm audible, guys? Yes. You guys are excited means command me in comment box. Raise your hands. Yes, Swati, Janaki, right. Thank you so much for your good reply. Yes. So most of the people excited. I am also excited to, entering into the day 4 class. Hi. Okay, happy learning all, happy learning. Now I am going to entering the topic. So what is the today's agenda? So today's agenda in the sense, what is the meaning of edge detection, why we learn edge detection, and we having the two different types for the edge detection. What does that means? What does that means? Sobel Edge Detection and Canny Edge Detection. Okay, two different kind of the edge detection we are going to discuss today itself. Okay, right. So now I am going to enter first of all, what is edge detection exactly? So already I said to you in the first slide, what is the meaning of that edges? In the sense, it is the boundary. It is nothing but boundaries. So it will be help to, for example, the edges are defined in a sudden and significant changes in the intensities of the image. And this can changes between the boundaries of the, it will be help to detecting the boundaries of the object. So where is the boundary here? So this is the image. So this is the image. This image, this is the boundaries. When you are going to apply the edges in the sun, this will be detecting, this will be help to founding the, boundaries of that particular image. Okay. So that is why I am saying edge detection is nothing but we are going to detecting the boundaries of this particular object. Clear now? Clear now? Right. So this is the edge detection. So why we are going to do that? So what is the purpose that exactly? Why we learned this in the sense? When you are going to, target like, object detection in the sense, we need, this is very mandatory to apply the edge detection. That means what? In the sense, in particular, visual, digital images or digital videos, the camera will be captured in one particular object, right? So here, now the camera is capturing in live session, right? So I am the object. But you can recognize what is the object. So this is Philip, right? So this is Philip, you can recognize. Human can understand where is the object. But what about the computer? The computer could understand to, with the help of the object detection this and all, right? So that means we need to processing on the edge detection. So edge detection in the sense, before we are, going to object detection in the sense, edge detection is very important. It will be help to the boundaries. So this is the boundary. This is the outline of the boundaries like this. Okay. So we need to, do this. And first of all, so what is the reason? So we having the, the sensible reason for detecting the edges we have. What is that? Because sometimes we can understand the shape of the object. But how it can be possible in the sense you can, understanding the edges of the image or edges of the object, then only you can understand easily. That is the sensible reason. That's why I mentioned here. One can understand the shape of the object in the image, that only the edges are detected. That only you can identify the object. When you are seeing the one digital images in the sense, that time you can understand how it can be possible in the sense. Once you are going to understood easily in the sense with the help of the edges, with the help of the boundaries. Clear now? Are you guys clear? Sure. 4AK. Yes, sure. Sorry for that actually. Yeah. So I will tell you slowly. Okay. So once you are going to understood that one particular image or particular object in this particular digital image, that time understand easily. Your edges of the image. So that is why I mentioned here. And also it will be help to detecting the edges. And one more thing, there are many technical issues and challenges to mapping the segmentation, registration, identification, technical. That techniques or edges, edge detection techniques will be proved to the efficient. About these techniques to the fundamental levels. So that is why I mentioned here. So segmentation, registration, identification. That means it is all this kind of the concept is basement is what is that in the sense object detection. Like every project in computer vision, it is depending on the object detection only. Without detecting the object, you can't do anything in the computer vision. Maybe that pattern recognition, face recognition, fingerprint, these all are the applications for the edge detection. That is very important. So what is the real-time application in the sense fingerprint, face recognition, object detection, pattern recognition? So that is these all are the the main important real-time application in edge detection. Clear now? Clear? Right. So now I am going to enter steps in edge detection. That is very important, right? When you are going to enter in the edge detection in the sense we need to understand these steps. Otherwise we won't do anything. Clear? So I am telling about the theoretical way. So once you are going to entering some of the concepts, this is a little bit confusing concepts. But I will say one thing. It is literally easy. Okay, so you can see the output in the sense that time only you could understand easily. Okay, right? Yes. Exactly, Mapiti. Exactly. So we are going to discussing about the localization sometimes. Okay, so we are going to discussing about the behind the function also. Yes. We have to correct it. If model is not performed very well in the sense, we have to correct it. Yes. Yes, if you need the PPT in the sense, you can join the internship, you will get. Okay? Right. Okay guys. So this is the steps. What is the step in the sense? First we have to, loading the image smoothing is necessary, and edge point detection and edge localization, so finally output will come. Okay, right, this is the process, this is the steps. Okay, right, now I am going to enter what are all the steps in the sense. Image smoothing is very important. So yesterday we were discussing about that. What is the meaning of image smoothing, what is the purpose of image smoothing, guys? So we were understood easily, right? So we were discussing about this yesterday class. Okay, the attendance link will be posted in 8:40. Don't worry. Okay, right. So image smoothing is help to reducing the noises, and it will be help to alter the quality of the image. Why? Because we are going to do that in the sense. With the help of the low frequency image, it will be help to finding the edges very easily. and processing very easily. So that is why image smoothing is necessary, because of that particular algorithm expecting that much Sobel or Canny. Okay, right. So now edge detection. So here I mentioned here, this is the perfect edge detection. See, the edges are detected. The edges are detected with the help of, it will be help to identifying these, certain changes of the intensity, and also, identify the edges, boundaries of the image, object. Okay, right. So that is why I mentioned here, it retain the edges of the image object. Clear now? Right? So edges localization. So it will be help to, this localization will help to linking the boundaries. Linking the boundaries. So once this link is, edges detected, but localization is very important here. So localization in the sense, we have to linking the boundaries. We have to linking the boundaries. It is not connected in the sense we have to continuity. Do the continuity, right? Okay, right. So types, what are all the types we have in the sense? Sobel Edge Detector and Canny Edge Detector. Okay, we are going to discussing two different types. So once you are entering the code and call that particular commands means, it will be very easy. So behind that function, it having some of the convolution process will be there. So what is the convolution? So convolution in the sense, it will be convolved with the matrix. Okay, right? So before we entering the coding and the types, I am talking about the internship. So if you guys are, willing to join the internship means what you will get. So if you are joining the internship means what you will get in the sense, 30 days learning activity. 30 days learning activity and OpenCV concepts. 7+ project you will be built and developed with me, and you will be get everyday recorded videos and also PPTs and all the materials for everyday classes. That video classes access for the 3 months. Okay, how to join that in the sense, the link mentioned in the command box and pinned in the command box. Overall, these particular video content, source code and project, this and all, it is nearly 26,000. But we are charging nearly 500 rupees only. Okay, 500 rupees only. Okay, right? So how to join that in the sense, by using the coupon code. By using the coupon code, most of the people asking one question. Yes. Muthukumar, you can see the output, then only you can understand easily. So it will be help to finding the boundaries of the object in the image. Yeah, you can get the PPT once you are joining the internship means, you can get the PPTs, recorded videos, this and all. Okay? Right. Okay, right. So here, if you want to join the internship means, use this particular link pinned in the command box. Okay, so use this coupon code, you will get offer nearly flat 500 rupees. Okay, 500 rupees offer, use this coupon code, that is coupon code OpenCV. Right? Okay. So now I am going to entering the Sobel Edge Detection. Okay. So in theoretical way, what is Sobel Edge Detector? So main purpose, we are going to detecting the boundaries of the object in the particular image. Okay, here when you are going to, what is the process? What is Sobel Edge Detector? So that we are going to discuss. This particular process, it will be help to calculating the x derivative and y derivative with the help of the x direction and y direction. Most probably the final output of, and we are going to discussing about the image gradient. So we have to calculate on that. After that only you are going to finding the boundaries of the particular object. Okay, this will be helpful for the which is actually some of the x edges and x direction edges and y direction edges of the image. Okay, so that is why I mentioned here the calculation of the gradient of the image intensity at every pixel within the image. That means what is our main objective of the Sobel Edge Detector? We are going to pointing the edges in the x direction and y direction. That is nothing but x derivative and y derivative. We are finally going to calculate the image gradient, that is g of x or g of y. After that finally g. Clear, no? So this is related to the gradient type and Canny is related to the Gaussian types. Okay, right. So what is the procedure? So what is the procedure? Most of the people asking questions. Yes, what is that? That's okay. Yes. Okay, guys. Yes, Banu Reddy. You will be asking one question. What is that? Can I get your Instagram ID? Yes, I will say one thing about this in at the end of the session. Okay, right? So definitely we'll connect with social media. So we are not planning till now. So actually we have a plan to connect with you guys in social media also. Okay, right? So now I'm going to enter in the procedure. So what are the calculation behind the function? Actually, what is the function we have in the sense? We have this much function only. We have this much function only. This is very enough. But behind this function, what is procedure for the Sobel derivative? Sobel Edge Detection. In the sense, these are the things we need to understand. So what is the calculation here? First of all, if we having the two kernels, that is 3 by 3 matrix. So one is, one of them is corresponding to the x. X is the horizontal and y is the vertical. The kernel shall be convolved with, original image under the process of the edges point. That will be convolved. After that, it will be finding the boundaries. So that is why I mentioned here. Finally, we are going to finding the, image gradient. Okay, the kernel values, shown below. That will be Sobel filter. That will cannot alter, but the Gaussian filter the Gaussian filter plays very well for the edge detection and it will be help to the detecting the boundaries. So we'll show that. So this is the procedure. What is the steps for the Sobel algorithm? So first of all, we need grayscale image. So if you need grayscale image, in the sense which function we are going to use, guys? So if you are going to converting the RPG into the gray, in the sense which function we are going to create, which function we are going to use. Guys, I am asking about the question. So if you guys answer in the sense, please comment in comment box. How to converting the color, which function we are going to use. So RPG into gray, this kind of the things, which function we are going to use. Yes, CV2 dot color BGR to gray, and the main function is CV2 color. Okay, so CVT color, right? Yes. Then yes, most of the people answer BGR to gray, and legend fun time. Yes, CVT color, convert color. Yes, PG gray, and yes. Thank you for the good answer. Yes, guys. Now I am going to entering the next step. We are going to calculate with the help of the Sobel X filter. That is X derivative. Next we are going to entering the Y, that is vertical. So vertical in the sense we are going to calculate the Sobel Y, that is vertical. X is a horizontal, Y is a vertical. And we are going to calculate the gradient, image gradient and the direction. So what is the procedure in the sense? So this is the way. Sobel X means this is a filter and it will be convolved with the X derivative. That means horizontal. Here Y means it is a vertical. So we are going to convolve with this, you can get it this matrix. Convolve in the sense 1 cross 1, I mean 1 cross minus 1 and 0 and 1, and after that entering that 2, I mean minus 2, 0 and 2, then 1 cross, I mean 1 multiplies minus 1, 0 and 1, this kind of the things you can get it. It is behind the algorithm. So the convolution is not a big deal. That means it will be convolved with this, I mean horizontal and vertical. That means nothing but ones and zeros, zeros and ones, this kind of the things. Once the x is 1 in the sense, that will be Sobel x, that is x derivative. Okay, right? In the same way, the y is also calculated like this. Say, see here, so minus 1, minus 2 and minus, so this kind of the process will happen like this. Clear, no? Right? After that, gradient calculation is very important. This is nearly to, I mean image gradient. Okay, so it may be that it will be bit of confusion, but once you are using that particular function mean, that will be very easy. But behind the, I mean function, you need to understand something, because of the convolution process will be there. Okay, so most of the people are asking attendance link, right? So attendance link will be updated on 8, will updated in 8:40. Okay, at 8:40. Okay, right. So now see here, I mentioned here the Sobel Edge Detector review. First, these two marks are applied in the image. So g of x, g of y, that is x derivative and y derivative. Finally, we are going to, I mean calculate the magnitude of the image gradient. That will be calculated with the help of this formula. So that means then the two output tables of masking and I mean image are combined. With the help of finally it will be smooth gradient magnitude output. See here how it will be convolved. This is the image. This is the x derivative. And once you are going to apply the y derivative in the sense with the help of the threshold value here. So this is the threshold value and this is the threshold value. Okay, once you are going to apply here in the sense, it will be convolved with all the values. Finally, you will be getting the gradient magnitude. In the same way also y derivatives. So this is the threshold value and this is the threshold value. Once you are going to apply to, convolve with all the values in the sense, you can get it this output for the gradient. Okay, I will show the code. Then only you can understand easily. So these are the functions for the Sobel Edge. Okay, these are the functions for the Sobel Edge. Here, this is the input, and this is the depth of the image, and this is the x derivative in the sense it will be horizontal and it means 1. Y derivative in the sense this will be 1. The kernel sizes it is nearly 1, 3, 5, 7. So that is mandatory. Okay, the kernel size is related to 1, 3, 5, 7 and 9. Okay, so I'm going to entering the coding right now. Open ideally guys, import. So first of all we need to loading the package and import numpy as np. Okay, right? So now going to load the image. That means cv2.imread of. So I am going to load one particular image, that may be that 3d.jpg. Okay, right. So this is the one particular file. So it will be helpful to finding the edges easily. So that is why I mentioned here. Then cv2.imshow of image original. Okay, so original, then entering the input. Okay, going to run this. Yes. Okay. This is the image we are going to apply the edge detection. Sobel Edge Detection. Okay, this is the image we are going to apply the edge detection. That is Sobel Edge Detection. Now we need to convert the grayscale. So CV2. So gray. So I command this, and it is not needed. So I command this. Then going to enter gray. Gray is equal to CV2 dot convert the color of image. So image, comma CV2 dot color PGR to gray, right? Right, now I'm going to show the image. So cv2.im show. So I will copy and paste here. It will be taking time, so that is why. Yeah. Now, yes, it is gray image, right? So gray, I mentioned here gray image. Now I will feed this particular variable like gray. Okay, right? So now I'm going to run this. So this is the gray image. Now I am going to apply the Sobel Edge Detection, that is calculate. We are going to calculate Sobel X. Okay, Sobel X equal to CV2 dot what is the function? So what is the function here? That is Sobel. That is Sobel. So now going to write that. So Sobel. So initially it is upper letter. So Sobel of, so I have to loading the image and CV-64F, that is the depth of the image. So say 64F, then this is x derivative, so that is why 1 comma 0 comma then k size. So this is the parameter. So this is the parameter, that is nothing but 5. I'm using here 5. Then CV2 dot, just a minute, CV2 dot im show of Sobel image or edges. Okay, Sobel image or edges. Then comma Sobel X. X. Okay, right? Now I'm going to run this. Just a minute. Yeah. Yes. CV2 dot. Just a minute. Yes. Run this. Yes. See here. You can get it in x derivative. You can get it in x derivative. But it is not clear. Okay. It is not clear. Why? Because of, just a minute. See, I'm going to use gray here. Okay. Gray. Then I will run this. Okay. See. So this is called the Sobel X derivative. Sobel X derivative. Okay, yes. 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 So Atman's link will be posted at 8:40. Yes, guys. Okay, I am going to finish this. Right. So in this particular concept, now I am going to entering the Sobel Y. Okay, Sobel Y in the same way. Sobel Y is equal to CV2 dot Sobel of gray, CV2 dot cb, the same depth we have to apply here. Yes, 64f. Okay, then 0 and 1, then k size is equal to 5. The same thing. Why? Because of it will be swapping, in the sense it is reverse. Why? Because of this is Sobel y. Okay, Sobel y. So that is why I copy and paste here. Then this will be y. Okay. Then this one edges y and this one edges x. Then I will run this. Right. See the differentiation between these and these. So this is going to detecting the edges. Why? Because of, see here. So some shadows will be there. It will be etched. And this will be there. It will be help to detecting the boundaries, but not much when comparatively Canny. Not much when comparatively Canny. Okay. Right. So that is why. Then I am going to entering the Canny. So then only you can understand easily. And also the Laplacian will be there. So Laplacian means, so Laplacian is equal to, so what is the function we are going to use that in this, and this is the Laplacian. Okay, here not needed to mentioning the derivatives, this and all. Okay, so now I am going to enter and type this cv2 dot Laplacian of gray, comma cv2 dot cv 64f. Okay, right. So then I am going to show this cv2 dot im show and Laplacian comma Laplacian. I copy and paste here. Okay, right, copy and paste here. Okay, clear? Right, I am going to end, run this one. See this? Just a minute. Yeah, Laplacian will not get the output, right? So what is the error will happen? We'll see that. Yeah. So what is the function? Laplacian. Just a minute. Then I will run this. Again, it will getting some error. And see this. Yes, see this. So it will be giving, yeah, so that spelling mistake will be there. Just a minute. Yes, yes. See, Laplacian. Okay. Then I am going to run this. Yes. So see the differentiation between the derivatives, x derivative and y derivative, and finally that yeah. So that then I will run this. See, this is the execution, final execution of the Sobel Sobel Edge Detection. Okay, clear now? Now I am going to entering the Canny. Okay, this Canny will be when comparatively Sobel. When comparatively Sobel, it will be giving the better result. Okay, better result. You can see the output. So this is the Sobel. Okay, and you can also see that Canny. I will show that, then only you can understand easily. Okay, clear all this, and now I am going to entering the explain about the, yes, Canny edges. Okay, Canny edge detector. So what is the purpose of this exactly? In the sense, the same purpose. So the same purpose in the sense, this will be helpful to extracting structural and object boundaries of that particular image. So if you choose one particular image, for example, if you choose one particular image, that particular image having the object, okay, objects. So this will be help to finding the boundaries of that particular object. So that is why I am saying, see here, to extract the useful structure information from the different vision of the object and dramatically reducing the amount of the data to be processed. So it will be applied in various computer vision tasks. That's why I am saying object detection. Why? Because in every concept, the object detection is very important. So without edges detection, the object detection is not possible to do that. Clear, no? Yes. I am going to write the code because what is already it is nearly 8:45, right? Yes. So I'm going to write. I clear all this. Okay, I clear all this. Not needed. Yeah. So what is the procedure for this? See. So first of all, we need to load the image. So what is the input the Canny Edge algorithm expecting in the sense that algorithm expecting grayscale image. Okay, and noise reduction is very important. So how to reducing the noises in the sense we are going to apply the Gaussian blur. So Gaussian blur is very important. It will be help to filtering and smoothing and blurring the image easily. It will be help to reducing the noises. So that is why I am expecting it will be help to remove the noises input from the input image. For the further process, what is the further process? We are going to calculate the gradient calculation, that is G, and next we are going to apply further subtraction. So we'll show that, then only you can understand this is the function. Okay, so this particular function actually expecting image smoothing. So that means we are going to apply the Gaussian blur. Gaussian blur is expecting. So once you are going to apply the Gaussian blur, after that is the input. So that is why I mentioned here blur. So this is threshold low and threshold high. Okay, right. I'm going to write the code here again. So once converting the grayscale image, I'm going to changing the image here, that is road. First of all, what is the output for the 3D image? After that, just a minute, what is the file name? Yes, I'm going to open. Yes, what is that? This is road and that one is 3D. Okay, right. So 3D dot jpg. Okay, then going to apply the blur. What is that blur? Is equal to Gaussian cv2 dot Gaussian blur of that particular gray image or whatever it is, gray image, gray comma, that we are going to apply that. What is that? That means kernel size 5x5, then that sigmox value. Okay, then after that we are going to apply, what is that? Canny. So Canny is equal to, yes, Canny is equal to cv2 dot Canny of that particular input image, that is blurred image, because of the Canny expecting image smoothen. So here we have to mentioning the threshold low and threshold high. After that cv2 dot im show of Canny, edges. Okay, then apply that Canny. Okay, so this is necessary. Okay, this is necessary. Now I'm going to apply this. So what is the output? We'll see that. See, we'll see that. So it is very clean, right? So it is actually very clean. It is actually very clean when comparatively Sobel. So that is why it performed very well when comparatively Sobel. So that is why this Canny edges, used in many of the, concept in computer vision. You can see the output, right? You can say differentiate with Sobel and Canny, right? Okay, you can differentiate between Sobel and Canny, right? Yes. Yes. So I'm close this, and I have to change something here. Okay. So here I'm not using, just using, or that color image. What will happen in the sense? We'll see that. Okay, the same will happen. The same will happen, but it is literally continuity. Okay, right. And I will be change one thing here. Yeah, gray is okay. Then I'm going to use one different image. What does that means? Lane. What is that lane? Means road. What is the file name? Road.jpg. Road.jpg. Now I'm going to apply this, all this. Yes, yes, you can't see, right? I'm going to resizing the image. Just a minute. Yes. So I have to resizing the image, after only it will be visible. Just a minute. Yeah. So image is equal to cv2 dot resize of image comma 600. So that means width and height. So 600 comma 500. Yeah, right. So now going to run this. You can see the output. Sorry. Yeah. And yes, this is Canny Edge Detection. Okay, once I am going to apply here without image smoothing, what will be happen? Without image smoothing, what will be happen? Just we'll try it. Okay, we'll try it. Here gray. I am going to apply the gray. Then I will run this. Yes, and yes. See, without applying the image smoothing, it will not detect, right? So here, so this is also edge detection. So most commonly when you are going to applying this one, this will be helpful for the lane detection. It is related to the once you are going to use maybe that Tesla. So that is one example. We have to find in the lane. Well, self-driving car is very important, these concepts. So without detecting the edges, in the sense that not possible to drive the car. Okay, that is why I chosen this lane. So here, once I apply this in the sense, just a minute, blur. That will be, the edge detection is very well. See. It can be possible, right? So it will be helpful for the detecting the lanes. Okay, so this is the differentiation between the Sobel and Canny. Sobel and Canny. Hope you guys are understand. It is literally confusing, but it will be, and once you are seeing the output in this and that, then only you can understand little bit. Right? Clear guys? Sorry guys, clear means please raise the hands in the comment box. Yeah. Yes, that is actually it is 8:53, right? Okay, we will be finishing soon. Clear, no? Clear? Okay. Yes. So if you guys are clear, means command me in comment box. Please raise the hands in the comment box. So I'm waiting for your comment. Yes, Rahul and Parthiban. So thanks for the good reply. Okay, don't call me sir, call me Philip. Don't call me sir, Mr. Chandrasekhar, call me Philip. So that is, more connected with you. Yes, clear. Murali Krishna, clear. So it is bit of confusing, but this concept is using many projects for detecting the object, recognizing the faces, the face detection, this kind of the things. Okay. So attendance link is pinned in the comment box. Clear. Thank you so much for your good reply. So please like the, if you like the session, means please hit the likes, and if you like the session, click the like button and do subscribe our channel. Do subscribe our channel for multiple technologies. You will be learn more from here. So if you like, means please like the session. Thank you Pawan. Thank you. And Shushmita, don't call me sir, call me Philip. Okay. So you people are all are my friends. So call me Philip. Don't call me sir. Thank you Abdul Karim. It is more encouraging words. That is move to the next step. So it will be very positive. Thank you. Easy to follow with your instruction. Thank you Abdul Karim. Thank you. So if you like, means please give the likes to the session. Hit the like button. Thank you Shreya. Thank you. Yes. So now I am going to entering my time. So yesterday I started, right? So now this is my time. Don't be afraid to start over. It's a chance to build something better. So that means I want to change the last line. Okay, I want to change the last line, because don't be afraid to start over. Just go with the flow. Don't worry. It will be happen. So once you are working on your dream, means it will be happen automatically. So that is why I chosen this, because of it will be connected to the yesterday's motivation also. So don't be afraid to start over. It is a chance to build something better. Okay. So don't worry. So just start. What is your wish? You can start right now. After that it will be go very easily. So go with the flow. It will be happen once you are working on that, in the sense it will be happen automatically, because of positive will come to you, because you are going in a positive way only. So don't be afraid at anything. So just start and go with the flow. So that is I want to say to you. So that is a bit of motivation to you all. Okay guys. Yes. Next. Yes guys. Yes, I hope you guys are understood today's concept. So today's concept is very important. This is the basement of object detection. So why? Because every project is related to the object detection only. Okay, right? Thank you all. So thank you. So yes, Srinu. Thank you. Thanks for positive vibe. Lakshmi, thank you. Thanks for your good comments. And Kalakal, okay. And I have to say one thing to you guys. So one of the interesting thing, you can connect with me in social media. We will be discussing in technical. So you have any doubts about computer vision, Python, machine learning, data science, in the sense we can discuss in that particular medium. So that is not planned right now. So it will be planned in soon. You will be connect with me. Okay. So don't worry. So I will share my Instagram or Facebook pages. Okay, we can connect in that particular medium. Okay, so we have a plan to connect with you, I mean with the help of Facebook or Instagram, okay, and WhatsApp also. So we will be discussing more in particular technique, like maybe that computer vision or machine learning, data science, this kind of the things. I'm also excited to connect with you guys. I hope you guys are also wanted to connect with me. Yes, of course, Raghava. Yes, I am from Tamil Nadu only. Yes, yes, that's good. Thank you. Thank you. So if you want to join the internship means use that particular link. It will be in the mentioned in the description. Use that particular link. You have to pay 500 rupees. So it is only for you. That is offer actually. So it is that particular packages is nearly 26,000, but we are giving the 500 rupees. Okay, if you join means you can get it all the recorded videos, PPTs, all the materials for everyday class. Yes, thank you. Thank you. Okay guys, you can join with me tomorrow itself. Tomorrow we have a class. We have a live. So no holiday, no holiday. Attendance link posted, pinned in the comment box. Yeah. So one person is asking Instagram ID. Definitely we will be, connect in that one particular medium. That is not planned. So if planned means we'll inform you in a live session. Sure. Definitely. Nalai Sandipom. Yes. Mr. Kyo. Definitely Nalai Sandipom. Yes, thank you guys, thank you. So it is more interactive. Thank you all. So tomorrow we will be meet in a different concept. Okay, different concept. We'll see you tomorrow. Have a delicious dinner and have a good dreams and live in positive way. Live in positive way. Don't be afraid. You can start today. What is your wish? So please work on that. Don't be afraid. Bye bye. See you and good night to all. We'll see you in the tomorrow classes. Bye bye. Boy all. Bye boy. Bye. Yes. Vineet, have a great day too. Yes, now I'm going to wind up. Bye bye all. Good night.